Hi guys, welcome back to the channel, and in this video we shall finally be starting the new topic, which is going to be greedy. If you have not watched the previous videos or you have not watched a single video, so please do check out the description. I put the link of the playlist. There are 86 videos and we have covered almost 220 problems. Many topics are almost done. Some problems here and there I will explain later with better understanding. So let us start with greedy today. Okay. So greedy is actually a very fundamental topic in the sense that there are nice problems in this also. There are kind of hard problems also, but most of the problems in greedy, just remember that, see, when we talk about greedy, right? So most of the time, in greedy problems, the approaches will involve these things only. Most common thing to solve greedy problem, you have to know sorting. So I think this is a must. Okay, you have to know sorting. Otherwise, it becomes very, very difficult if you don't know sorting. And this is very fundamental. Most of you will obviously know this. Then you have to also know maybe two-pointer method. Okay, this also helps. Some problems two-pointer method is also there. So a greedy problem will be a combination of one or more of these concepts. You also have to know min heap, max heap. These basic concepts, if you know, na, it will be easy only. And then brute force also, which is obvious, you will know it. So greedy problem you will identify very easily. Most of the problems you can identify it is greedy. So in this topic, there is no problem in identifying. The only problem will might come in implementation. Like which one should I do sorting? Will it be the best approach? Or should I use min heap, max heap? Which one will be best? Sometimes this is better, sometimes that is better. Or sometimes should I just go with the brute force idea? Maybe should I take extra space instead of increasing the time complexity, should I take extra space? So that also will come into picture. Okay, so let us see some fundamental problems in greedy. Actually, in this topic on spodge, I hope everybody knows spodge. Yeah, so on spodge there are nice problems as they are present in the list. So what I'll do is these spodge problems I will solve together, some separately. Fundamental problems I will take separately. And there are also very nice and specific problems. What do I mean by specific? That means method to solve them is only one. Like you have to approach in that way only. There are not multiple methods. And there are quite standard problems. And also some problems are repeating in this list. I will tell you what are repeating. The name has been changed, that's it. So let us see some fundamental problems today. So let us start with this one. Maximize sum of arr of I into I of an array. So by seeing the problems, the question itself, by seeing the question itself, you can guess what's the problem. You will be given an array of integers and we have to write a program to find max value of this expression over here. So we have to find the max value and we have to take mod. So modular arithmetic is very important. It will come anywhere. It can come wherever, in whichever topic. So modular arithmetic, if you don't know, I'll quickly tell you. See, modular arithmetic is uh, if you want to take mod with, suppose you want to take mod with C. Okay, so how do you do A plus B mod C? If you want to do A plus B mod C, it is equal to A mod C plus B mod C, the whole mod C. So this is a basic property of modular arithmetic. You can check a GFG article on this. there is a GFG article, it is sufficient. You will understand modular arithmetic nicely. Okay, so this property we have to remember to solve this problem. And moreover, that is not the only thing. What we should do is, see from the problem itself, isn't it obvious that we have to sort the array? Why is it obvious to sort the array? Let us take a simple example. If suppose the array is going to be 1, 3, 4, 2. Okay, and indexing. So this is the array of I, and let us say I. The indexing is from 0. So 0, 1, 2, 3. Now what is summation of array of I into I in this case? Summation of array of I into I will be what? It will be 1 into 0, which is 0, plus 3 into 1, 3, plus 4 into 2, 8, plus 6. How much is this? Going to be 17. This is going to be 17, right? But now, instead of this permutation, what if I do this? 1, 2, 3, 4. Now what is going to be my summation array of I into I? 4 into 3, 12, plus 6, plus 2, which is going to be 20. So what I'm trying to say is, let's remove all this. If you want to maximize this expression, array of I into I, because I increases, if I increases and array of I also increases, then our answer also increases. So for these two conditions should be to be satisfied, we have to sort the array. So we have to just sort the array and then do normal calculation. So with mod, how you do it is in this way. So be careful with mod over here. Don't make a mistake. So with mod, there are other ways to do it also. I have done it in this way just to make it more readable. So I will put the answer in the description, okay? And you can check it out over there. So this was a very fundamental problem which was only based on sorting. Let us see another problem. Maximum sum of absolute difference of any permutation. So we will be given an array and we need to find maximum sum of absolute difference of permutation of a given array. So let us take this example. I hope it's visible for everyone. Let us take this example, okay? 1, 2, 4, 8. So what they're saying is, so suppose the array is 1, 2, 4, 8. Now what are they asking us to do? They are asking us find maximum sum of absolute difference. What does this mean? What do you mean by absolute difference? So according to the problem statement, absolute difference will be whenever we consider two adjacent elements, what the absolute difference of that is, and we have to keep taking sum. So for example, in this case, it will be 1 minus 2 mod plus 2 minus 4 mod plus 4 minus 8 mod. So this is what they're saying by the absolute difference. But this is not the entire problem. We have to do what? We have to maximize this value, this answer that we get, right? This answer that we get, we have to maximize it. So what is the best possible way? Which permutation of this array will help us in getting the maximum answer? So you can do trial and error, and after doing trial and error, you will come to know that If you want to get maximum absolute difference, first thing is sort the array. So first thing is sort the array. Okay. So in our case, it will be 1, 2, 4, 8. Okay. After sorting the array, now what? Now take the first element or take the smallest element. So I'm starting from here and from here. Take the smallest element, then take largest element, then take the second smallest element, then take the second largest element, like that. So pick one element from left side, pick another element from right side, and keep doing this until you have picked all the elements. So this is again based on sorting only. You just need to know sorting, and obviously time complexity will be n log n because of sorting. So just sort the array and take one element from left side and one element from right side, starting from the left side. Why starting from left side? To get maximum answer, to get maximum value, to take it, because this element, it will be common to both of them, so the answer will increase. If the permutation was this, right, if the permutation was going to be this, I think the answer would be different, or maybe it would be the same. Let us see. 7 plus 3 plus 2, 12. Here 7 plus, the answer will be different. So this is better. So start from the left side. I'll just erase all this and tell you. So after sorting the array, start from the left. Take the first element, then take the last element, then take the second element, take the second last element. I think this is very easy to understand. This is a very easy problem, and I think you would have understood by now, right? What I'm trying to say. So that was this problem, maximum sum of absolute difference of any permutation. Otherwise, if you have not yet understood anyway, the same thing is written in this article also. You can look at it. Next problem, we'll quickly see. These are all fundamental easy problems. Just get a good grip on them. Given an array of non-negative integers, our task is to find minimum number of elements such that their sum should be greater than sum of rest. Minimum elements such that sum should be greater than rest of the elements of the array. Okay. So what approach I will use for this problem is, I hope everybody have read the problem statement. Pause the video and read the problem statement by yourself. So what I will do is, so to solve this problem, what will be my algorithm? What will be my algorithm to solve this problem? First is find sum of array. Find sum of all elements of array. Next will be sort the array. Okay, I will sort the array. Third is traverse array from right side. Traverse array from end. Traverse array from end. And keep taking the sum. Let me explain this with an example, why I am traversing array from the end. Let us take an example, okay? Suppose, let us take any random example, 3, 5, 2, 4. Okay, what is the sum of the array? Step 1 was find sum of all elements of the array. What is it going to be now? It is going to be 14. Sum is equal to 14. Second step is sort the array 2, 3, 4, 5. Okay, so array is sorted. Now third step, traverse from the end and take the sum. Now, when I traverse from the end, this is the array. I am at this point. When I am at this point, let us say my sum s is equal to 5. When I come over here, my sum s will change to 9. Now you see the sum of these two elements is 9. But can you tell me what is sum of remaining elements? Sum of remaining elements will be 14 minus 9, which is equal to 5. So now we have a subset. Subset can be anything. Subarray and subset are different. Subarray means it has to be continuous only. But subset doesn't mean that. That is why you can sort the array. Because they have told subset, we can sort the array. And we will take all the large elements, because when we take all the large elements, our the minimum, we will get minimum number of elements such that the sum will be greater than the remaining sum. That is why we have sorted the array. And now we can see that by taking all the larger elements, we need few elements such that the sum will be greater than the remaining elements. So that's all the problem is. So I'll just repeat it. I think you can write the code by yourself. It is very, very easy. Take the sum of the array. Okay. Sort the array. And then start taking the sum of all elements from the right side and compare if the sum is greater than remaining sum. How to do that? I'll just elaborate on that part. So let us say this sum is array sum. Let us say this sum is array sum. And let us say this S is sum of elements from right side. And be careful before doing, you have to sort the array. Otherwise you will get wrong answer. So if at all you get a condition like this, if sum is greater than sorry, I'll just take another color. See, if S is greater than, what is remaining element sum? Sum minus S. Then break out. And obviously keep a count variable to count how many elements you are taking. As in when you traverse the array from right side to left side, you will be traversing and taking the sum. That time keep a count variable also to count how many elements are there. And if this condition is to just break out, otherwise do count plus plus and increase sum and increase this S, as I had explained in the previous example. So to solve this problem, there is nothing else. You have to just sort. You should just know sorting. Time complexity, I think, will be n log n. Yeah, sorting means n log n only. And you can see over here only. So for this video, that's all from fundamental problems. We'll see and move on to tougher problems in the next upcoming videos. Okay, please share the channel with all your friends. If you like my video, please do hit the like button, subscribe to the channel if you have still not. Support me. You can connect with me on LinkedIn and Instagram. All of that will be in the description. And check out the playlist and my solutions. That also is in the description. And please do sign up on InterviewBit with the link in the description. InterviewBit is a very good platform to solve coding problems. So please do check that out also. Thank you for watching this, and I'll see you in the next video. Take care, stay safe, keep learning and keep growing. Bye.